Okay, so in this video, I'm going to show you guys how to multiply radicals in a couple of different kind of levels of difficulty here. So let's start with the easiest one. So let's say I have something like 2 root 3 and I'm multiplying that by 4 root 5. Okay, so in order to do this, we need to remember a rule that I showed you guys from a couple of videos ago, and that rule is the following. That if we take the square root of a and we multiply that by the square root of b, we get the square root of a times b. And remember that in this case, a and b would typically just be numbers. So we need to remember how to do that. We need to remember that rule when considering this sort of thing. So here's what we're going to do first of all. These are both mixed radicals, right? 2 root 3 is a mixed radical with a coefficient of 2, and 4 root 5 is a mixed radical with a coefficient of 4. So when multiplying radicals like this, I'm going to start by multiplying the coefficients. So I'm going to do 2 times 4. Okay, well 2 times 4 is 8. And now that I've multiplied the coefficients, I can multiply the radicals. So that's root of 3 times root of 5. Well, root of 3 times root of 5 should be the root of 3 times 5. Right? And 3 times 5 is 15, so that's going to give us the root of 15. So 2 root 3 times 4 root 5 is just 8 root 15. So that's the easiest level of difficulty for these kinds of questions. Let's step it up a notch here. So what happens if I have something like 2 root 3 and I'm multiplying that by root 2 plus 4 root 5? Right? So this looks kind of like a distribution property question, and that's exactly what it is. So I'm going to multiply this 2 root 3 into the set of the brackets one at a time like that. So I'm going to multiply both terms inside of the brackets by 2 root 3. So it's kind of like an example of the first problem 2 times, right? So 2 root 3 times root of 2. Well, root of 2 has a coefficient of 1, so I'm going to multiply the coefficients, right? So 2 times 1 is just 2. And then I'm going to do root 3 times root 2, which is just root of 6. Okay, now I'm going to multiply 2 root 3 times positive 4 root 5. So 2 times 4 is positive 8. Root 3 times root 5 is root 15. Okay, so you treat this just like a regular distribution property question. Okay, now I want you to take a look at 2 root 6 plus 8 root 15, which is what we got here. Now, neither of those are simplifiable. So there's no perfect square number that divides 6, and there's no perfect square number that divides 15. So those are as simplified as you can get. But also notice that they are not like radicals, which means I can't add them together. So I just leave them as 2 root 6 plus 8 root 15. All right, let's make this one step harder then. So let's say I have something like this, 2 root 3 plus root 2. All right, that's one big binomial radical, so to speak. And I'm going to multiply that entire thing by 4 root 5 plus root 7. So I'm multiplying two sets of binomials that are created out of radicals here, okay? And we're actually going to do this the exact same way we do regular radicals. So I'm going to multiply each term in one binomial by every term in the second binomial. So to start with, I'm going to do 2 root 3 times 4 root 5, and then I'm going to do 2 root 3 times root 7, okay? And that's going to give us, well, 2 root 3 times 4 root 5 is 8 times the square root of 15. Okay, 2 root 3 times root 7. Well, the coefficient of root 7 is 1, so 2 times 1 is 2, so plus 2. And then we have root of 3 times root of 7, which is the root of 3 times 7, which is 21, so root of 21. And now that I've multiplied 2 root 3 by everything in the second binomial, I'm going to multiply root 2 by everything in the second binomial. So root 2 times 4 root 5, well again, root 2 has a coefficient of 1, so 1 times 4 is 4. Root 2 times root 5 is the square root of 10. And root 2 times root 7, well they both have a coefficient of 1, so 1 times 1 is just 1, which means we don't need to put a coefficient. And root 2 times root 7 is just root 14. So we get root of 8 root 15 rather, plus 2 root 21, plus 4 root 10, plus root of 14. Now, none of the radicals that we have here are divisible by perfect squares. 15, 21, 10, and 14, none of those are divisible by perfect squares, so we can't simplify them. And also, none of them are like radicals, which means we can't add them together. So this is our final answer. Anyways, this is 3 levels of difficulty for multiplying radicals. Take care, guys.